This is the start of the collapse of World Trade Center No. 1, also known as the North Tower. We are here tracking the motion of the roofline at 0.2 second intervals through approximately 32 meters, or 8 stories. This graph shows the height of the roofline as a function of time. The analysis is simpler if we plot velocity as a function of time. On this kind of a graph, a straight line indicates constant acceleration. First note that there is a sudden onset of collapse, as the point we are tracking makes a sudden transition from being at rest to an approximately constant downward acceleration. The slope of the graph indicates that the acceleration is 6.31 meters per second squared downward, which is 64% of free fall. In other words, once it starts falling, the upward resistive force is only 36% of the weight of the falling section of the building. So far, so good. But now turn it around. Newton's third law says interactions between objects work both ways. The forces two objects exert on each other are always equal and opposite. If the upward force acting on the falling block is 36% of the weight of the falling block, the downward force exerted by the falling block must be exactly the same, 36% of the weight of the falling block. In other words, the top section of the building is exerting less force on the lower, stronger, undamaged structure than it would if it were simply sitting motionless. Therefore, as long as the top section of the building is in uniform downward acceleration, it cannot possibly be providing sufficient force to destroy the building. This may seem counterintuitive to you. You might think a falling block coming down on the lower section of the building would exert a greater force than a stationary block. But that is true only if the falling block actually impacts the lower block, which would cause the falling block to decelerate. The only way the falling block can continue to accelerate smoothly, as we see here, is for the lower section of the building to give way without significant resistance. If this rate of acceleration continued all the way to the ground, the building would fall in about 11.5 seconds. This is close to the observed collapse time. So far I've been using the term block loosely. What we actually see here is the falling section of the building turning to dust before our eyes. But what is happening to the upper section of the building behind the dust clouds doesn't really affect this analysis. Given the fact that it is accelerating downward, the top section of the building, whatever its condition, cannot possibly be destroying the lower section of the building. The destruction of the building must be caused by something else.